let's say we have some cars moving. One guy is going along a street straight. So here is going to be the first car. Say he's driving this way with BB, and he's accelerating with AB. And then let's say there's a circular track here. Car A is driving along the track with velocity VA, and say that speed is constant. And radius of the track is R. And we'll call this angle here theta. So if we're given a theta at this instant, VB, acceleration of B, and VA, and we want to find velocity of A with respect to B and acceleration of A with respect to B. So let's say theta equals 30 degrees. And velocity of B, 5 meters per second. And then acceleration is 1.5 meters per second squared. And A, speed can be 6 meters per second. So this acceleration, the actual vector is going to be down because velocity and acceleration here, those are both down. So negative, negative. So what are we going to do about this? Well, we have the vectors drawn, so procedure. Step 1, we need to break velocities and accelerations into components. Step 2, use relative formulas. Okay, so to break these into components, we need to write the vectors for each one. So we'll start with B because we can see exactly what direction that is going. Velocity of B equals negative 5 j hat because it's going 5 in the negative y direction. Acceleration of B equals negative 1.5 j hat. Now A is a little less straightforward, but still not too bad. We know this angle right here is 30 degrees. And we know that velocity is going to be always tangent to the radius of the curve. This is a right angle, which means that this angle is also theta. So now we can break velocity of A into components. So velocity of A is going to be, in the x direction, we'll have I hat times 6 cosine theta, because it's going positive, and then also positive j, 6 sine theta. Which if we simplify this, since theta is 30 degrees, then we know that this is going to be 3 square root 3 I hat plus 3 j hat. That's meters per second. Now acceleration of A, VA is a constant speed. This is given. Well, if VA is a constant speed, is there any acceleration? There is no linear acceleration, but there is radial acceleration because it's going in a curve. The magnitude is not changing, so there's no linear acceleration, but the direction is changing. So there is some angular acceleration. So acceleration of A, we know that we need to take the derivative of velocity. So that is dv dt so taking the derivative of this, we'll get derivative of now the 6 is a constant, but theta is changing because A is going around this curve. So in the I hat direction, we'll have 6 times the derivative of cosine, which is minus sine, so negative sine theta d theta dt, because this is chain rule. Theta is changing, so we take its time derivative. And then we'll have plus j hat times 6 theta dot cos theta. But then what is theta dot? Well, think about how quickly is theta changing. It's got to be related to that speed right there, and it's related to the radius. Now, if theta dot is in radians per second, velocity is in meters per second, r is in meters. Theta dot equals v over r. So we need to use this thing. For that, we must be given r. Let's say r equals 30 meters. So theta dot equals 6 over 30 equals 0.2 radians per second. So now we can plug that, and we plug in theta into here. So acceleration of A equals I hat times negative 6 times 0.2 times, sine theta is 1/2 plus j hat 6 times 0.2 times square root of 3 over 2, which equals negative 0.6 I plus 0.6 square root of 3j. Okay, so we finished this one, breaking velocity and acceleration into components. So next we need to use those relative formulas. Here it's just plug and chug. We know velocity of A with respect to B equals velocity of A minus velocity of B. So we'll have in the I hat, velocity of A, which is 3 square root 3. And VB does not have an I component. So then minus in the J direction, because we're subtracting, so in J we'll have 3 minus a negative 5. So if we put numbers in here, then we get 5.2 I hat plus 8 J hat meters per second equals velocity of A with respect to B. And for acceleration, we have a similar process. Acceleration of A equals acceleration of B plus acceleration of A with respect to B. So I hat component, we have negative 0.6 from A. And then the J hat component, we have 0.6 square root of 3 minus this negative 1.5. So that comes out to be negative 0.6 I hat plus 2.5 for J hat meters per second squared equals acceleration of A with respect to B. So to summarize, in order to find relative velocities and accelerations, first we break each one into components. Sometimes to break it into components, will have to find the angle and use sine and cosine if it's not going straight. And then once you find the components, you just subtract them using the relative velocity formula to get the answers.